So next topic is node analysis with voltage source. So we are going to discuss about a supernode. Supernode. This is very important. So I will explain this. Right. So here is this a circuit? The given circuit, you are interested to find V1, V2 and V3. And of course this is a V3 is a non-reference node. Now this is a 0. V3 is equal to 0. Right. So to find V1 and V2, we have to apply the first KCL at this point. So you now at this case KCL, we cannot apply KCL because there is a voltage source in it. See, just to check the difference in the previous problem and this problem. See, this voltage source, the 10 volts voltage source is connected between non-reference node V1 and reference node V3. We never come across this situation. So in this case, what we can do? Simply we can set V1 is equal to 10 volt. When a voltage source is connected, this is actually case 1. Then if a voltage source is connected between the reference node and the non-reference node. So we simply set V1 is equal to 10 volt. That you have to remember, right? And the second case, what happened? This V2 and V3 are two non-reference nodes. Between two non-reference nodes, the voltage is there. Okay, so this is the case 2. So there a supernode is going to form when a voltage source is connected between two non-reference nodes. We form a supernode. So the case 2, case 2, if the voltage source is connected. The voltage source is connected between two non-reference nodes. Between two non-reference nodes. The two non-reference nodes. The two non-reference nodes form a supernode. Form a supernode, or we can say generalized node. Generalized node. So then we apply KCL and KVL to determine the node voltages. That we have to remember, right? So what the case to say that if the voltage source is connected between two non-reference nodes. So this is the voltage source. 5 volts if the voltage source is connected between two non-reference node, right? So what happens? Here the supernode will be formed. How we are going to determine the supernode? Just by applying KCL and KVL, we can determine the node voltages. So what is the supernode here? What is supernode? Supernode is formed. A supernode is formed by enclosing a dependent, okay, dependent or independent. Dependent or independent voltage sources between two non-reference nodes, and any element is connected, and any element is connected in parallel. With it. Okay. So this is the supernode. Supernode means what? How supernode is formed? It is formed when the voltage source is connected between two non-reference nodes, and two parallel elements are connected parallel to it. Any resistor elements here, any resistive element connected here, any element connected parallel to that. Okay, this is how two cases, and a V1 and a V2. So we find this problem. Now here we are going to find V1 and V2, and V2 we have to find it. So we have to find V1 and V2, and V3 we have to find it here. So to find that, so just see that simple, it is a V3, this is a V3 is equal to 0. This is a non-reference. So as I told you, our aim is to here to find V1, V2 and V3. Right. So here V1 is equal to 10 volts. Simply set V1 is equal to 10 volt, because 10 volt source is connected between V1 and V3. Right. So next, how to find V2 and V3? You just see that this is this 5 voltage source is connected between two non-reference nodes. So what you have to do? This is actually super node. We just make a one circle. So that is, we call it a super node. It's a super node. We call it a super node, right? So then we have to apply KCL and KVL. Now we apply KVL at super node. Apply KCL at supernode. Apply KCL supernode. So you just see that this is a node. This is entirely node. This one. So this is a node entirely. So inside the node, I1 is entering into the node. So I just taken as a plus I1. Then I2 is leaving. I2 is leaving. So minus I2. Right. Next, here I4 is entering. so plus I4. Then I3 is leaving, so minus I3 is equal to 0. Minus I3 is equal to 0. So what is I1? I1 is connected between V1 and V2. So I1 is equal to V1 minus V2 by 2. I1 is equal to here. I1 is equal to V1 minus V2 by 2. Then I2. Where is I2? I2 is here. The I2 is connected between V2 and V3. So V3 is 0. So I2 is equal to V2 by 8. Right? Now, what is I3? I3 is equal to, I3 is connected. See, I3 is flowing. Here 6 ohm resistor is connected between V3 and of course this is a V4. We have another V3 here. Right. So I3 is equal to V3 minus here V3 minus V4. V4 is 0 by right. Then I4. So this is I4. This is I4. Okay. I4 is connected between V1 and V3. V1 minus V3 by 4 volt. So now substitute all these values. So I1 and I2 are substitute in this equation. This is equation 1. So we substitute here. So what do you get? This is the equation you have to substitute. In this equation, I substitute I1 and I2, I3 and I2. Right. So now substitute here. So what is I1? Just I am going to write like this equation. I1 plus I4 is equal to I2 plus I3. I2 plus I3. Right. So what is I1 here? I1 is equal to V1 minus V2 by 2. Right. What is I4? I4 is equal to V1 minus V3 by 4 is equal to, what is I2? V2 by 8 plus, what is I3? V3 by 6. V3 by 6. So where is I2? I2. Right. So what is LCM here? LCM is here 4. So you will get 2V1 minus 2V2, right, plus V1 minus V3, right. So what is the LCM here? The LCM is 24. So then 3V2 plus 4V3. So just cross multiply, or you can cut it. 4, 1, 4, 6. Right. So what is the left here? So I'm going to write here. So 2V1, or you can this you can cross multiply here, or first you can calculate it. So here 2V1 and V1, that will be 3V1 minus 2V2 minus V3, okay, is equal to here 3V2 plus 4V3. This is by 6. Okay, I am cross multiplying here. Right. So how much you will get now? 18V1 minus, this is 6 into 2, 12. 12V2 minus 6V3. Okay, then this I am going to bring it this here, minus 3V2 minus 4V3 is equal to 0. Then 18V1 How many V2s are there here? 12 V2 minus 12 V2 here, and here is minus 3 V2. How much total? Is it 15 minus 15 V2 V3 minus 6 V3, so minus 9 here, minus 6 minus 4, so you will get altogether 10 V3 is equal to 0. So this is a one equation. This is a one equation, right? This is a one equation, we got it. So I'm going to erase this one. So we got 18V1 minus 15V2 minus 10V2 is equal to 0. Right, what is the V1? V1 you already know that the V1 is equal to 10 volt. We already know V1 is equal to 10 volt. So 18 into 10 minus 15 into V2 minus 10 V3 is equal to 0. Right? So this is 180. This is 180 minus 15 V2 minus 10 V3. Now we will bring it this side is equal to 0. Now this will be 180 which is equal to 15 V2 plus 10 V3. 10 V3. Take common 5 here, so you will get here 36, and this will be how much? 3 V2. This will be 3 V2, and this one will be 2 V2. 2 V2. So by applying KCL, we got one equation. Right? Now what you do, we are going to apply the KCL at Supernode. So you just see that Supernode. Here we apply the KCL, and now we are going to apply the KVL. How we are going to apply the KVL? So this Supernode is connected here, right? Supernode is connected here. So all other whatever connected will vanish, and whatever is connected to the parallel also, all branches will be removed. I'm just going to write like this. So it will be like this. So this is a V2, right? This is a V2. And V3. And this one is the plus and minus. So this is a 5 volts, right? This is a 5 volts. And this and all branches I'm going to remove it. Okay. Whatever it is connected. Okay. So here is, I'm going to take it as a this is the plus V2, and this one is the plus V2. Now apply the KVL. Now apply KVL. Apply KVL. When you apply KVL here, see, this is entering through minus 2, minus V2. And after that a plus 5. Okay. Then it will come plus V3 is equal to 0. So minus V2 plus V3 is equal to minus 5. Minus V2 plus V3 minus 5. Now we have two equations, we can solve it. Equation 1 and equation 2 you can solve, so you will get node voltages. You already know V1 and you already know V1. so I'm going to write like this. Minus 3V2 plus 2V3 is equal to 36. This one. minus V2 plus V3 is equal to minus 5. So again what you have to multiply with the 2. When you multiply with the 2, what happens? So you have to multiply with the 2, then you will get so this is 3V2 plus 2V3, then 36. So this is minus 2. Actually you can multiply with the 3. You can multiply with the 3. So minus 3V2, okay, then plus 3V3, then minus 50. Okay, then we both get cancelled. 5V3 is equal to, so what's the value you will get? This is 36, 50. So how much you will get? This one is 11. 36 minus 15 is 11. 11. So you will get V3 is equal to 11 by 5. Now we can easily find V2 value, right? So what is the V2? You take any equation, you can find it. So I am going to take from equation 2. Equation 2 I am going to find the V2 value. So from equation 2, V2 is equal to V2. V3 is 11 by 5 minus 5 minus V2 is equal to minus 5 minus 11 by 5. So how much you will get? Minus V2 is equal to, this is, take LCM here, so you will get, this is 5 minus 25 minus 11. Okay, so minus V2 is equal to minus 36 by 3. So you will get 12 volts. So these are the V1 and V2, V3 values. So you will get the V1, you already know 10 volts, and the V2 is equal to 12 volt, and V3 is equal to 11 by 5 volts. So these are the nodal voltages.